G'day guys. Okay, so we're back. What I'm in the process of doing is I'm just reverse engineering this board like I said I was going to do in the short little video I uploaded before, so I can show everybody what's going on here. But I'm just going to pause. I'm going to finish taking some measurements. I just want to measure the capacitors, finish mapping out a few other components that aren't on here. Then we'll come back and we'll talk about what's actually wrong with this circuit and why it's oscillating and what we're going to do to fix it. So we are getting there, guys. So far I have found a little bit of decoupling for the microcontroller on one of its input pins. I think maybe an ADC input, probably from the op amp. I haven't traced that far yet. Also a small capacitor to bypass its positive rail. Another capacitor on the output of the regulator, but still no capacitor on the input of the regulator, just 150 ohm resistor and a Schottky diode. So I'll keep going on this and I'll be back in a minute. Okay, so we've made some discoveries. I did find one capacitor that's filtering the power rail, but it's after this diode, which is after the resistor, which I find odd because you would normally put a diode there going into a cap, then a resistor and another cap if you really wanted to filter it with a resistor. It just, yeah, it doesn't seem right. Anyway, I'm just tracing out what appears to be an op amp now, and I'll get back to you with the rest of the circuitry. But I have one thing I will point out is a couple of the traces I've drawn are not actually laid out like that on the board. There is a half decent ground plane in some areas, but in other areas there isn't. So let me explain just briefly. These negative rails that you see that I've drawn going over things, they're actually just coming off ground plane on the board in between stuff. It's a multi-layer board, so there's traces on the top, traces. The back's just one plane, and then there's traces inside. But yeah, it's not that bad as what it looks like in my diagram, but it is not good either. So I'll continue tracing it out, measure all the cap values, and then I'll get back to you with what I'm going to do to fix this oscillation problem. Alright guys, so I've traced out a schematic here. The only problem is there's a couple of capacitors that I can't measure their values correctly in circuit, even with an LCR meter at different frequencies. So I'm going to have to take them out of circuit, take those measurements. I did screw up a couple of times and put traces and write figures in the wrong, well, I almost wrote 100 nano for these two caps before I realised my readings were thrown off from them being in circuit, and I almost drew a trace in the wrong place. That was just too close to that. I didn't want it to be too messy for you guys, so I moved away just a little bit, but yeah, just put some tape over my errors and kept going instead of redrawing the whole thing. So I'm gonna just take off some of these capacitors, because this capacitor measures a different value to this one, but they look identical to the eye. That doesn't mean anything, but we want to know. And the same with this one, because this measures the same value as this one, but it looks a lot bigger. So just going to have a look at this. It could just be voltage ratings and stuff like that, but it doesn't really make sense because this is the 3.3 volt cap, and that's the cap that's on the input side, which could be up to 33 volts. So it would make sense that that cap would be physically bigger if they were both the same value. So I have to desolder these guys. I'll be back shortly. Okay, so I've just swapped the leads on my LCR meter over from the Kelvin clips to the Kelvin, if you want to, almost Kelvin. The two wires join just there, so you got a straight piece of metal. It's not really two wires, 4 wire sensing, 2 wires on each side, you know. It's almost. Anyway, I digress. I got the LCR tweezers out. I've taken that bottom cap off. So I'll start at 1 kilohertz. Oops, didn't really work. Not the best quality tweezers. Oh, look at that. That one really was 100 nanofarad. Okay, so we'll note that down. 100 nano. I won't bore you guys with me taking all the caps off the board, but I'll just take off one just to show you how quick and easy you can do it with just a soldering iron. That's the other capacitor right there. We'll test that one. Noting that this is the first one, this is the second or higher one on the board. Well, the solder on that, how do I explain this? Has a bit of a sharp edge. I'm just gonna get rid of that so when I go to test it, it doesn't go flying on me. Because if I lose it, then I've got to pull apart another meter to find out the value. It's not so much that I don't have caps lying around, but it won't be good if we lose the cap before we measure the value. So they're both actually 100 nanofarad. Okay. So I was right when I said that these two being smaller than that one didn't make sense for the values that I got. I am glad that I took them out of circuit. 100 nano for both of those. Alright. I'll put these two back on the board and I'll take these two little ones off. So let's just see what the LCR says in circuit. .4 microfarads on that one. About 1 microfarad on that one. Let's try in the other direction. Same, about 1 micro. Okay, so these readings seem consistent, but they seem like 2 different value caps. I'm going to desolder them because they're in circuit and that could be skewing the values too. I'll just pause the video whilst I put them two back and take them two off so I don't bore you guys. But yeah, we're almost there, and then we'll go over the circuit once we've got all the values there and talk about what we're going to do to fix the oscillation problem and why I think it's there in the first place. I'm going to try powering it up before I do make any changes off of a battery just to see, even though it's now powered off of a way quieter power source than the LM7812 that was powering it before, I still want to see what it does on a battery. I suspect it's going to do the same thing, but who knows. Anyways, I'm getting carried away talking again, so I'll pause the video, I'll put these caps back on the board, I'll take these ones off, measure their values, note it down, and then we'll go over what we're going to do. I don't want to edit these things out, guys. You're going to find this so funny, but in the last video, you saw me pick up a resistor and fling it, and it was just a little surface mount resistor, and I was like, man, I'm never going to find that. Well, I just tossed one of those little 100 nanofarad capacitors on the floor. I went to pick it up. Look what I found. That is the 20k resistor I dropped the other day. Not that I need it. Anyway, I'll have a quick look on the floor for this little capacitor. If I can't find it, I'll just go grab another one. I've got plenty of them, it's not a problem. Be back soon, guys. You know, guys, on second thoughts, I'm actually just going to move this cap off to the side because I'm going to change a lot of different components around on this board. The style of component, the value, if it's there at all. There's not really much point in putting them back on when they might be coming off or being changed. So for now, I'll just continue taking these other two off and see what values they are. We don't need to worry about anything because we now have a circuit diagram with all the values that were originally there. So I'll just go continue taking that and those two capacitors off. So these last three, measure them. I'm pretty sure that's 10 microfarads, but I'm still going to measure it out of circuit just in case. And yeah, we'll go from there. We're back in a sec. Thought I might just video this bit too because these capacitors are really small and I don't want to get the soldering iron in there and make a mess of it. So I'm going to take them off with hot air. Trying to keep hot air away from this board as much as possible, but in this instance I'm going to use it. That's the one on the left. That's the one off of the right. I'll just quickly clean these other pads. A bit of solder wick. Then my wick is a little bit shit, I'll just cut that off. Alright, it's weird, it was like the wick had no flux in it there. Alright. Right, that's cleaning up nicely. Did such a good job, I took the 150 ohm resistor off the board too. That doesn't matter because that was something else I was gonna change and remove, so they can go off to the side. We don't need that anyway. Right. So these little capacitors. That's right, they went that way. So that one was from there. Good thing I took a video, eh? Yeah, no, that's right, they went that way and that way. That one was there, that one was there. So let's now measure those values. I hope my head hasn't been in the way. Ah, oh, I'm an idiot. I'm sorry, guys. I think you can tell I'm new to YouTube. One of my cats has just come in the room. Junior, can you please get out? Junior says no. As long as he doesn't jump up, we're all good. Okay, so one microfarad, like it actually measured in circuit. $100 nano. So we got, let's see here. A top capacitor which was connected to the middle pin on this op amp. Oh, they both are, that's the ground point. My bad. Okay, the capacitor closest to the micro. It goes to the micro, it's 1 microfarad. and the little one on the inside is 100 nanofarad. Okay, so now we know the component values on the circuit. We can talk about what we're going to do with it. So this 1 microfarad capacitor is decoupling, I don't know what, because it's not the same pin that the op amp's going into on the micro, but it's decoupling something on the micro. The other capacitor, that's obviously just, it's a smaller value. You know, you've got your 10 microfarad capacitor here across the regulator. That's for bulk storage reasons. The small 100 nanofarad capacitor across the 3.3 volt rails, obviously for, how do I say this, high frequency stuff, small spikes and stuff like that. That 100 nanofarad capacitor I'm going to change. 1 micro I'll leave. The reason for this is these little surface mount ceramics, especially when they're in really, really small packages, they have really bad properties compared to ones in even bigger packages that are still surface mount, or your traditional ones like this. So this is a 0.1 100 nanofarad monolithic capacitor, and let me just see if I've got one in the back here. Yeah, that's a 1 microfarad monolithic capacitor. If you test the parameters on these over a wider frequency range, so if you put it on your LCR meter and start at say 100 hertz and measure it all the way up to 100 kilohertz, you'll notice that these guys have got lower ESR and the capacitance stays more where it should be without dropping in value, whereas these little multi-layer, what do you call them, multi-layer ceramic MLCC caps, they're rubbish basically. So yeah, that's a real trap for young players when you're designing circuitry and you end up using a whole load of MLCC caps. Just bear that in mind. Their values can change with frequency, with voltage, with temperature, and greatly with all of these things. And when I say greatly, I don't just mean like by a percent or something small, I mean a huge deal. You know, there are some caps that will be 10 microfarads up to say 10 kilohertz, and then all of a sudden they hit 100 kilohertz and they're not even measuring 100 nanofarads. You'd be quite surprised how frequency has an effect on them. Same thing with voltage with these little MLCC caps, it has a massive effect on them. I mean, these things have an effect on all different capacitors, but these little guys are the worst for it. So what I'm going to do, I'm going to put a 1 microfarad really low ESR monolithic capacitor where this 100 nanofarad bypass cap was for the power rail on the micro. The reason for this is because the other day when I had my scope ground lead coiled up as an antenna, I was picking up some very high frequency spikes coming off the micro. Could be from its clock generator, it could be from ADC sampling, it could be from a few things. Anyway, I want to bypass that with a higher value and a lower ESR, so we'll probably actually use that exact capacitor right there as a matter of fact. The 1 microfarad that's bypassing something on the micro, I might actually get the data sheet and pause the video and get the data sheet, have a look at what pin it goes into and actually see what it's doing. If it's something I feel that's important, we'll upgrade that to a better type of capacitor. If it's not, we'll just put back the one that's there. The biggest thing here well, let me just say first off, this 10 microfarad capacitor, initially I'm going to leave it, but the first thing that I'm going to change is I'm going to remove this Schottky diode. I'm going to change this to 100 ohm resistor. Actually, I'm just going to put a 10 ohm resistor there, and I'm going to change this 100 nanofarad capacitor to 1 microfarad. So no Schottky diode, 150 ohms will be 10 ohms. There'll be a 1 microfarad capacitor there. Here, this is, I don't know what it's doing. It looks like there's some sort of snubber network here going to ground off of one of these pins off of this device that could be an op amp. I'm pretty sure it is, but I don't know what that's there for, so I think I'll just put another normal, like the one that was there, 100 nanofarad back there for now, and see how we go. But yeah, I'm going to eliminate the diode, drop that resistor to 10 ohms, up this capacitor to 1 microfarad, leave that 100 nano for now, and put a 1 microfarad capacitor there, and leave that 1 micro. So I'll get into that now, and I'll come back when the work's done, or maybe halfway through I'll come back and video some of it. I don't want to sit here and just bore you guys talking and working, so I'll just pause the video again for now. Alright guys, so I've done the most annoying thing ever. As you can see, I put this little capacitor back. Then I realised, in all of the telling the cats to get out of here and thinking about the fact that I'm hungry currently, I mixed them up, didn't I? And then when I started looking at this, I was like, man, am I sure that those are the values that was there? So I'm just to make 100% certain, what I'm going to do is I'm going to make this a 2-part video. I'm going to pause it, and then well, not pause it, sorry, stop recording here, and just, yeah, watch it back, have a look at what I've screwed up with these 2 caps, which is the 100 nanofarad, which is the 1 micro, and then I'll make a part 2 video. But I need to watch my own footage to see my own screw up. I'll be the first to admit it, I do these things a bit. I'll see you soon, guys.